Let us now solve some problems in permutations and combinations. The first question is, number of ordered triplets of natural numbers ABC for which ABC is less than or equal to 11 is option A 52, option B 53, option C 55, option D 56. Let us calculate. Here, what are ABC? First of all, they are natural numbers, provided the product ABC must be less than or equal to 11. The product ABC must be less than or equal to 11. Therefore, what can it be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What are these? The product levels of ABC. ABC, no doubt it is a natural number. It must be less than or equal to 11. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or at most 11. Let us gather the number of ways. If the product is 1, how many ways it can be done? 1, 1, 1. 1 into 1 into 1. There is only one triplet. So, to have the product 1, it is 1. For 2, for 3, for 5, for 7, for 11, you observe all these numbers, these are prime numbers. To have the product, there is only one way, 1, 1, 2. To have product 2, the numbers must be 1, 1, 2. How many ways they can be arranged? 3 factorial by 2 factorial. 3 factorial by 2 factorial. That is 6 by 2. That is how many ways? 3 ways. Here 3 ways, 3 ways, 3 ways, 3 ways, 3 ways. How many total? 1, 2, 3, 4, 5. 5 3s are 15 ways. Well, let us now think of getting the product 4. Product 4. How can that product 4 can be done? 1, 1, 4 is one way. 1, 2, 2 is another way. Any more ways? No more ways. Here 3 factorial by 2 factorial. Here 3 factorial by 2 factorial. Altogether 2 into 3 factorial by 2 factorial. That is equal to 6 ways. Next, product 6. Product 6. What are the possibilities? 1, 2, 3. 3 factorial. Next, 1, 1, 6. Any more? 1, 2, 3. Product 6. 1, 1, 6. Product 6. Any more 3 integers whose product can be 6? No more. This can be done in 3 factorial ways. This can be done in 3 factorial by 2 factorial. Therefore, 3 factorial plus 3 factorial by 2 factorial. These are 6. These are 3. Total 9 ways. For 6. For 8, what is the number of ways? 1, 1, 8. That is one chance. 1, 2, 4. That is another chance. Another chance. 2, 2, 2. Any more? 1, 1, 8. Product 8. 1, 2, 4. Product 8. 2, 2, 2. Product 8. This can be 3 factorial by 2 factorial. This can be 3 factorial. This can be only one way. Total 3 plus 1, 4 plus 6, 10 ways. Well, for 9, how can you have the product 9? How can you have the product 9? What are the ways? 1, 1, 9 is one way. 1, 3, 3 is another way. Any more ways? Any more ways to have 9? No more. This can be in 3 factorial by 2 factorial ways. This is also in 3 factorial by 2 factorial ways. That is 6 by 2. 3 plus 3, 6. The last 10. In how many ways can you have the product? 1, 1, 10. 1, 2, 5. Any more? No more. The first can be in 3 factorial by 2 factorial ways. This can be in 3 factorial ways. Total 3 plus 6 it is 9. Let us now add all of these. What will be the sum? 9 plus 6 15 plus 10 25. 25 plus 15 40. 40 plus 15 55. One more is here. 56. How many ways you can choose 3 numbers you can arrange? You have the product ABC less than or equal to 1 and arrange them as a triplet. Is just nothing but 56. That is the 4th option. Here we are not asked justly to have the selections only. Triplets order is also fixed. So it is a permutation mixed combination problem. Total number of such triplets is 56. That is the 4th option is the right option. The next question, that is question number 2. The number of different words that can be formed by using all the letters of the word Shashank, such that in any word the vowels are separated by at least 2 consonants, is option A 2700, option B 1800, option C 900 and option D 600. Let us first observe what is the word given. The word given is Shashank and the restriction is put on vowels only. Let us see the question once again. In any word, the vowels are separated by at least 2 consonants. Luckily here only 2 vowels are there. What are the vowels? A and A. Let us keep them aside. First of all, what are the remaining letters? Remaining letters, how many are they in number? 6 letters. What are the 6 letters? S, H, S, H, N, K. How many ways can you arrange them? This can be arranged in 6 factorial by how many S's are there? 2 S's are there. How many H's are there? 2 H's are there. They have been arranged. Now the question is to arrange the vowels. How many vowels are there? 2 vowels are there. They must be separated in such a way that between these 2 vowels at least 2 consonants must be there. Let us first of all observe the possible places here. 1, 2, 3, 4, 5, 6, 7. There are 7 gaps here. Out of these 7 gaps, if you put some A here, then another A must be here. So some 7 gaps are there. Out of these, let me place 1 A at 1 gap. Let me place 1 A at 1 gap. Say some rth gap. In rth gap, I put 1 A. You imagine. Then suppose I put 1 A here. Where should I put another A? Here or here? You are supposed to leave these 2 blank places. You are supposed to leave those 2 blank places. So how many blank places are still remained? 7 minus R minus 1 places have been remained. How many places are remained? 7 minus R minus 1 places are remained. There only you are supposed to put another gap, so another A. In that gap only you are supposed to put the second A. Here are only 2 A's. We are concentrating on one particular A. Let us first assume that it has been placed at one particular, say, rth gap. The second A, that is the second vowel, must be placed in the remaining 7 minus or minus 1 gaps only. Why? Because 2 vowels must be separated by at least 2 consonants, he has said. Therefore, the total number of combinations will be 6 factorial by 2 factorial into 2 factorial into sigma 7 minus or minus 1 factorial, or running from 1 to 5 only. Why? Because there are only 5 remaining gaps there. You observe this sum. If you could calculate this, this comes around 2700. You please expand that summation, taking or is equal to 1 to 5. So that the answer will be 2700. That is the option A is the correct option. Let us turn our head towards the next question, that is question number 3. The position vector of a point P is R bar is equal to xi bar plus yj bar plus zk bar, where x, y, z are natural numbers, and a bar is equal to I bar plus j bar plus k bar. These are two vectors given. One vector is R bar, which is of course the position vector of the point P, and another general vector A bar is I bar plus j bar plus k bar. If R bar dot A bar is 10, the number of possible position of P is, that is, how many such position vectors R bar can exist with the condition R bar dot A bar is equal to 10. He has given R bar dot A bar is equal to 10. By satisfying that given condition, how many points you can have with the position vector R bar? That is the question. Let us observe that. What is the position vector given? R bar is equal to, what is R bar? Xi bar plus yj bar plus zk bar. What is A bar? I bar plus j bar plus k bar. What is the condition imposed here on P? R bar dot A bar is equal to 10 he has given. R bar dot A bar is equal to 10. What is R bar dot A bar? Xi bar dot I bar, that is x plus y plus z is equal to 10. Well, we want to have the number of solutions for this equation x plus y plus z is equal to 10, provided x, y, z are natural numbers. What does it mean? The number of positive integral solutions of this equation x plus y plus z is equal to 10. We could have discussed already in the synapses. If you want to have non-negative solutions, then it will be n plus r minus 1 c r minus 1, and if you want to have positive solutions, it will be n minus 1 c r minus 1, that's all. So here the number of solutions for this equation such that each solution is a natural number is n minus 1 c r minus 1. n minus 1 c r minus 1, that is 10 minus 1 c 3 minus 1, that is 9 c 2. If you can calculate 9 c 2, it will be just nothing but 36. Therefore, two options are correct among the given. The option A is correct and option D is also correct. Two options are correct in this question. It's very simple and straight question. It is just enough if you are able to remember that the number of positive integral solutions is n minus 1 c r minus 1. We now discuss with the next question, that is question number 4. The number of divisors of 2 square into 3 cube into 5 cube into 7 power 5 of the form 2n plus 1, where n belongs to n is. It is an interesting case. We are not asked to have the total number of divisors. We are supposed to have only divisors which are in the form 2n plus 1. You may have to recollect that 2n plus 1 is the standard form of an odd number. That is, we are asked to have the number of odd divisors. So in those divisors, 2 or 2's should not take part. Why? Because we just want to have odd divisors only. Because 2n plus 1 is the standard form of an odd number when n is a natural number or an integer. Of course, in the present problem it has been given that n is a natural number, whatever it might be, 2n plus 1 is surely an odd number. Therefore, we are supposed to have odd divisors, the number of odd divisors. How can it be? You ignore 2 square. The remaining prime powers are 3 cube, 5 cube, 7 power 5. So the total number of divisors with that part only, by considering the odd numbers only, how can it be? 3 plus 1 into 3 plus 1 into, what is the exponent given to 7? 7 power 5 it seems. 5 plus 1 minus 1. That is 4 into 4 into 6 minus 1. 4 4s are 16. 16 6 are 96. 96 minus 1, that is 95 is the right answer. That is option B is the right option. Let us switch over to the next question. That is question number 5. In this question, the number of ways of painting the 6 faces of a cube with 6 different given colors is. There has been a cube. We know that it will have 6 faces and 6 different colors have been given you. You are supposed to paint all the 6 faces with 6 different colors. How many ways can you do? The important concept and thing that you have to observe here is all these 6 faces are not linear. They are not one by one, side by side. You must observe that. Okay, let us first paint one of the sides with one color. One face, one color. You can do that in one way. Forget it. You have painted one face with one color. Well, you now paint the exact opposite face. It can be done in 5 ways. Why? Because one color has been painted on one face. Still you have 5 more colors. With those 5 more colors, you can paint the opposite face in how many ways? 5 ways. That is one action, 5 ways. Now, you observe it carefully. You have a cube in your hand. This face has been painted and the exact opposite face has also been painted. Now the remaining 4 faces are to be painted using 4 remaining colors. Here we have to understand the situation very carefully. These 4 are appearing in a circular way. These 4 faces are not linear. Therefore, these 4 faces can be painted with the remaining 4 different colors in 4 minus 1 factorial but not 4 factorial. Why? Because these are to be considered circular. So, the number of circular permutations of 4 things is 4 minus 1 factorial. 4 minus 1 factorial. What is 4 minus 1? 3. 3 factorial means 6. The total. By using fundamental principle of counting again, here 2 pieces of work have to be done. The first piece of work you could have done in 5 ways and the second piece of work we could have done in 3 factorial ways, that is 6 ways. Totally, both the things can be done together at a time in 5 into 3 factorial, that is 5 into 6, 30 ways. How many ways? 30 ways. So what is the right option? Third option, that is option C is the correct option. The number of ways of painting all the 6 faces of a cube using 6 different colors is 30, that is 30. Option C is the correct answer. Let us switch on to the next question, that is question number 6. Here 2 points are given, capital A 1 2 and capital B 5 5 are 2 given points. Starting from A, line segments of unit length are drawn either rightwards or upwards only in each step until B is reached. Then the number of ways of connecting A and B in this manner is option A is 35, option B is 40, option C is 45, option D 50. Let us now check it. First of all, what are the given points? 1 2 and 5 5. Let us observe the points in the first quadrant. Let us observe the points in the first quadrant. 1 2 3 4 5. 1 2 3 4 5. The first point given is 1 2. It lies here, say, imagine. And the second point given is 5 5. It lies somewhere else here. We are supposed to move from A to B not in a diagonal way. Either rightwards, upwards, rightwards, upwards, rightwards, upwards, like that only you are supposed to move. In each step, you are supposed to move for one unit only. What is the way? How many ways you may have to reach from A to B? Observe the points first of all. The first point is 1, 2. The second point given is let us first observe the x-coordinates of the points. In the first point it is 1 and in the second point it is 5. So you may have to move from 1 up to 5. How many right steps are needed? 4 right steps are needed. Why? Because the difference between the x-coordinates is 4. How many right steps are needed? 4 right steps are needed. Let me represent those right steps are. Now, difference between the y coordinates. What is the difference between the y coordinates? In the first point, the y coordinate is 2 and in the second one it is 5. Therefore, the difference is 3. So, from 2 you may have to reach 5. How many steps you may go up? 3 steps you may have to go up. So, how many upward steps are needed? 3 upward steps are needed. Which is to be applied first and which is to be applied next? As you wish. How many ways can you arrange these steps? It's very simple. How many are they in number? 7. 7 factorial by 4 r's are there, 4 u's are there. So 7 factorial by 4 factorial into 3 factorial. It is of course just nothing but 7c3 or 7c4 even. So this is 7c3. It is nothing but 35. What is the answer? 35. Among the given options, it is the very first option, that is option A is the right option. Let us see the next question. That is question number 7. The number of 5-digit numbers which are divisible by 3 that can be formed by using the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9 when repetition of digits is allowed. Repetition of digits is allowed. How many digit numbers you require? 5-digit numbers are required. Therefore, how many places you may have to fill up? First place, second. We are supposed to form 5-digit numbers. It means that we are supposed to fill 5 places, 5 boxes using those digits. 1, what are the digits given? 1, 2, 3, 4, 5, 6, 7, 8 and 9. The crucial word involved in the problem is repetition is allowed. Therefore, one more thing, we are lucky not to have 0 in the data. In the given set of digits, 0 is not included. We should feel happy. We need not take any special care about the first place. Well, first place can be filled in 9 ways because out of all those 9 digits, you can use any of the digits in the first place. Similarly, second place, 9 ways. Third place, 9 ways. Fourth place, also 9 ways. The first 4 places have been filled. They can be filled in 9 into 9 into 9 into 9 ways. That is 9 power 4 ways because the repetitions are allowed. The repetitions are allowed. Now the right question is the way of filling the last place. Well, what type of numbers we require to have? Those numbers which are divisible by 3. When can we recognize that a particular number is divisible by 3? If the sum of all the digits in the given number is divisible by 3, then the number is divisible by 3. Therefore, enough precaution is taken to fill the 5th place in such a way that the sum of all these digits is divisible by 3. What are the digits? We do not know. But of course, 3 cases may arise. The sum of all these 4 digits is either in the form 3n or in the form 3n plus 1 or in the form 3n plus 2. Only 3 cases. Suppose this sum is in the form 3n. Then 5th place must be filled either by 3 or 6 or 9. How many ways? 3 ways. Well, if at all the sum happens to be in the form 3n plus 1, then with what type of digits you may have to fill the 5th place? Either 2 or 4 or 6. How many? 3 chances. Suppose the sum of all these 4 digits which you have already filled is in the form 3n plus 2, then with what type of digits? You may have to see that the total is divisible by 3. With the same thinking only we would have done by filling the last place with 2, 4 or 6. Think of in the same way. The sum of the digits which have been placed in the 4 places is in the form 3n plus 2. In order to maintain that the total is divisible by 3, the 5th place must be filled either by 1 or or 4 or 7, because 1 plus 2 is 3, divisible by 3. 2 plus 4 is 6, divisible by 2 plus 7 is 9, divisible by 3. So this sum of the digits which have been placed in the 4 places may fall in one of the cases only, either this or this or this. Only just one and only one of these 3 cases happen. In any of the cases, the last place could be filled in how many ways? 3 ways only. If this is the case, 3, 6, 9. If this is the case, 2, 4, 6. If this is the case, 1, 4, 7. Like that. Therefore, the total number of ways of filling all those 5 places, the total number of ways of filling up of all those 5 places could be done in, come on, how many ways? 9 into. The total number of ways is 9 into 9 into 9 into 9 into 3. This is 3 square, this is 3 square, this is 3 square, this is 3 square, the last one is 3. All together it is 3 to the power of 9. Is it available? Of course, in the option A it is available. Therefore, the right option is option A. The first option, 3 power 9 is the correct answer. The next question is question number 8. The number of 4-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9, such that the least digit used is 4 when repetition of digits is allowed. A peculiar type of condition has been put forth here. The least digit that must be used is 4. That is, even though 1, 2, 3, 4, etc. up to 9 digits are given, you are not supposed to use 1, 2 or 3. You are supposed to use 4, 5, 6, 7, 8 or 9 only. Why? Because the least digit that must be used is 4 only. Okay, how many such numbers will be there? Of course, repetition of digits is being allowed here also. In this problem also, we have seen that the repetition of digits is allowed. Well, let us go through the option. The first option is option A is 617. Second option is 671. Third option is 716. And the fourth option, that is option D, is 761. Which one is correct? Let us see. First of all, what are the digits given? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of these digits, what type of numbers you are supposed to have? 4-digit numbers. What does it mean? You are supposed to fill 4 boxes. Okay. One more condition is there. The least digit that must be used is 4 only. So, you are not supposed to use 1, 2, 3. How many are possible? 4, 5, 6, 7, 8, 9 only. Okay. right? Therefore, how many ways you can do that? First place, 6 ways. Any of these 6. What are those 6 digits? 4, 5, 6, 7, 8, 9. Second place, again. Third place, again 6 ways. Fourth place is also in 6 ways. Okay. All these are 6 power 4 in number. Is it the right answer? No, one more thing you have to use here. You have to think of. The least digit used is 4. Therefore, in these 6 power 4 numbers, there might be a chance of without using a 4 also at any place. Yes, you observe this number, 7,896, 4-digit number. 4 does not appear here. Such numbers might be there. No, we must not have such numbers. The least digit is 4 among all those numbers. Therefore, we may have to subtract those numbers in which 4 is not used at all. Those numbers must also be found here. Let us find them. Let us now find them. Without using 4 means 4 is also neglected. How many possible numbers are there? 5. 5, 6, 7, 8, 9. That is without using 4. How many? Without using 4, how many such 4-digit numbers can be formed? Let us see. Again, 4 places are to be filled without using 4. How many ways? The first place in 5 is 5 is 5 is 5 is. Why should we say 5 is? Because 4 is not used here. 5, 6, 7, 8, 9. Only 5 possible digits are there to be put in those 4 places. Therefore, such numbers, how many such numbers will be there? 5 power 4. Our required number of numbers is total numbers minus those numbers in which 4 is not used. Total number of numbers minus those numbers in which 4 is not used. So what is the answer? 6 power 4 minus 5 power 4. You just calculate that. What is 6 power 4? 12, 9 is 6. What is 5 power 4? 625. You just subtract it. The answer is 671. That is option B is the right option. We shall now see the next question, that is question number 9. The number of arrangements of the letters of the word Navalavanyam which begin with N and end with Yam is, he has given 4 options. 16 factorial by 7 factorial into 3 factorial whole square, 16 factorial by 7 factorial into 3 factorial, 14 factorial by 7 factorial into 3 factorial into 2 factorial, and the last option, that is the 4th option, is 14 factorial by 7 factorial into 3 factorial. Let us see. This is a beautiful word and a peculiar word. Let us see. What is the word given? Navalavanyam. That is the word. What is the condition put forth on the nature of arrangements which begin with N and end with M we should have? So, start with N and end with M. Therefore, forget about one N and one M. Forget about one N and one M. You count the number of letters which lie between these two. 3, 4, 7, 10, 13, 14. These 14 letters are to be arranged in the middle without disturbing the last M and the first n, you are supposed to arrange all the remaining 14 letters in the middle. It is straight and simple, no question of any extra condition. It's very simple. How many are they in number? 14. 14 factorial by, come on, count. How many A's are there? 1, 2, 3, 4, 5, 6, 7. 7 A's are there. And again, V's. How many V's are there? 1, 2, 3. Next, A's we have counted, V's we have counted. How many N's are there? N. 2 factorial. And again, A's over V's over A's over L's. There is only one. If you want to have one factorial, you have it, no problem. Next one, A's over Y. There is only one Y. You need not write anything. Therefore, this becomes the answer. That becomes the answer, and it is available, of course, in the third option, that is option C. In the given options, that is the answer. That is 14 factorial by 7 factorial into 3 factorial into 2 factorial is the correct option and answer. Now, the next question before us is question number 10. In this question, two numbers A and B are chosen from the set of natural numbers 1, 2, 3, 4, etc. 3n. In how many ways can these integers be selected such that a square minus b square is divisible by 3? He is asking about a square minus b square, not about a plus b or a minus b or any other thing. We are inquired of a square minus b square. A square minus b square must be divisible by 3. What will be the total number of such numbers? The first option, that is option A, is 3 by 2 into n plus 1 plus n square. Second option is 3 by 2 into n minus 1 plus n square. The third option is n into n plus 1 by 2 minus n square. And the fourth option is n into n minus 1 by 2 plus n square. Let us have a check. Let us examine that. Okay, what are the given set of natural numbers? 1, 2, 3, etc., 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 3n. Well, first of all, let me list those natural numbers in a special way like that in the board. Let me arrange them. 1, 2, 3. 1, 2, 3. Next, 4, 5, 6. Next, 7, 8, 9. Next, 10, 11, 12. Next, observe the list of numbers in the first row. 1, 4, 7, 10, 13, like that. You please observe, they leave a remainder 1 when divided by 3. Observe the second row of numbers 2, 5, 8, 11, 14 and so on. What is the character of those numbers? Every number in that row leaves a remainder 2 when divided by 3. And similarly, what is the character of the numbers which have been listed in the third row? 3, 6, 9, 12 and so on. They leave the remainder 0 when divided by 3. That is, these are all multiples of 3. Like that, what will be the last number in the third row? 3n. What is the last number in the second row? 3n minus 1. What is the last number in the first row? 3n minus 2, isn't it? 3n minus 2. 3n minus 2. Well, like this, I could have listed all the numbers from 1 to 3n. Okay then, what type of benefit we are going to get if you could have listed those natural numbers like this? What type of benefit? You observe, you take any two elements here. Difference is divisible by 3. Any 2 here. Difference is divisible by 3. any two you choose in this row, difference is divisible by 3. The third row has an additional benefit also. What type of benefit that is? If you select any two numbers in the third row, their sum is also divisible by 3. The reason of dividing all the 3 unnatural numbers like that in 3 rows is we are supposed to have some type of numbers which are divisible by 3. Let us focus on that. What is a square minus b square? It is a plus b into a minus b. By looking at this, we can take the decision. You are supposed to choose the two numbers a and b in such a way that either their sum is divisible by 3 or difference is divisible by 3 or both. That is, a plus b is divisible by 3 or a minus b is divisible by 3 or both a plus b and a minus b are divisible by 3. Such a pair of two integers a and b you're supposed to choose. How many ways you can do that? First of all, if you take any two numbers here, difference is divisible by 3. How many numbers are there in the first row? N. Altogether 3n numbers are there. So each row contains n natural numbers. Out of those n, you can choose 2 in NC2. Any two numbers here have their difference divisible by 3. Therefore, this row also you can choose 2 numbers. Similarly, this row also you can choose 2 numbers. Is it enough? No, we have seen that the number of ways of choosing 2 numbers whose difference is divisible by 3. Of course, in the third row we have got a double benefit. What is this double benefit? Both the sum and difference is divisible by 3. Well, in order to have the two numbers whose sum is divisible by 3, should you take the two numbers from the third row only? Not necessary. There is another chance. Take a number in the first row, take a number in the second row, add them. You see what is going to happen. Say 1 plus 5, 6 divisible by 3. Say 7 plus 2, 9 divisible by 3. 4 plus 11, 15 divisible by 3. 3n minus 2 plus 3n minus 1, 3n minus 6n minus 3 divisible by 3. Therefore, to have the sum of the numbers divisible by 3, you can choose one integer from the first row and one integer from the first row and another integer from the second row also. NC1 into NC1. This is the way you can simplify that. NC2 plus NC2 plus NC2. What is that? 3 into NC2, that is 3n into n minus 1 by 2 plus NC1 into NC1. What is NC1? N. N into n square. So plus n square. Well, let us check. What is the right option available? Option B is the right option. Here, the only thing is you have to get the plan of arranging the given set of natural numbers in these 3 rows, and it of course facilitates us to choose the pair of numbers whose sum is divisible by 3 and product is divisible by 3 and both. Yes, so the answer, the right option and the right answer is option B, that is 3n by 2 into n minus 1 plus n square is the right answer. The next question before us is question number 11. In this question, the number of distinct rational numbers of the form P by Q, where P and Q are natural numbers from 1 to 6, that is P, Q belong to the set containing 1, 2, 3, 4, 5, 6 is. That is the question. So we are supposed to form rational numbers of the form P by Q. Of course, every natural number will be in that form only, P by Q. He is restricting us about Q, P and Q. They must be taken from 1 to 6 only. That is the condition. How many such rational numbers are there? First option is 23. option B is 32, option C is 36, and option D is 28. Let us examine which option is the correct option. P, comma, Q belong to 1, 2, 3, 4, 5, 6. Let us observe, there are 6 cases possible. Let us observe. P is equal to 1. What are the possible rational numbers? 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. How many such things are there? 6. Suppose P is equal to 2. 2 by 1. 2 by 2 do not occur. Why? Because 2 by 2 is 1, which has already been counted. 2 by 3. 2 by 4 do not occur. Why? Because 2 by 4 is half, which already exists. 2 by 4 is not appearing here. 2 by 5, 2 by 6 do not occur. Why? Because 2 by 6 is 1 by 3, which is already counted. How many are they in number? 3. Suppose P is equal to 3. 3 by 1, okay. 3 by 2, okay. 3 by 3 not okay, because 3 by 3 is 1, which is already counted. 3 by 4, no problem. It comes under 3 by 5. It is also okay. 3 by 6, no. What is 3 by 6? It is half. It is already counted. Therefore, how many are they in number? 4. Suppose P is equal to 4. What happens? 4 by 1, okay. 4 by 2, it is 2. No, it has already counted. 4 by 3, okay. 4 by 4 do not come under count. 4 by 4 is 1. 4 by 5, no problem. 4 by 6, it is 2 by 3. It is already counted. Therefore, how many are they in number? 3. Suppose P is equal to 5. How many are they in number? 5 by 1, okay. 5 by 2, okay. 5 by 3, okay. 5 by 4, okay. 5 by 5, no. 5 by 5 is 1. It is already counted. 5 by 6, okay. Count them. How many are they in number? 5. If P is equal to 6, what happens? 6 by 1, okay. 6 by 2 means 3. Okay. No, not okay. 6 by 3 is 6 by 2 is 3, already counted. 6 by 4, 3 by 2, already counted. 6 by 5, 6 by 6, no. 6 by 6 is 1, already under count. So it is 6 by 1 and 6 by 5. 2 are in number. Therefore, all together, these are 23. Therefore, what is the right option? 23 is the right option. First option, option A is the right option.